In this hint, we're going to talk about production theory and production functions. And we're going to start by just thinking about what production involves. Traditionally, we look at production in economics as a kind of like a black box. And inside this black box, what happens is what's represented by the production function, and what comes in are inputs to production, and what comes out are outputs. Okay, and we often refer to these inputs to production as factors of production, and these include labor, capital, and we usually talk about land as incorporating both actual land and other types of items from nature, such as raw materials. And finally, entrepreneurship, which can be considered an aspect of capital, or it can be spelled out separately. So these are our factors of production. Our outputs are usually referred to as goods and services. Okay. Goods and services. Okay. Now, something that we generally forget to talk about is that all of this economic production generates wastes. Okay? And here's where we'll get into concepts such as negative externalities or pollution. That will be later in the course. So now we're going to develop a short-run production function. Now, what the short run part of this means is that there must be at least one input that is considered to be fixed in the short run. And we're going to make this the capital, plant and equipment and so forth. And K usually stands for capital in economics. So we're going to leave capital fixed. And what we're going to vary, we're going to have a graph here where what's going to vary from on the x-axis is going to be the variable input, which in this case is going to be labor. So we're only going to be looking at capital and labor as our inputs, which we're going to ignore anything from land and anything from entrepreneurship. Now, what is on the y-axis here is going to be O for output, or we sometimes use TP for total product. Okay, so what we're saying in this graph is that holding the fixed input constant, that as we increase our variable input, labor here, that we're also going to have an increase in our output, or total product. And we can draw these in various shapes, but a classic way to do this is to consider that for a while, as labor input is increased, output might be going up faster and faster. Do you see how this is curving upward as it goes? Okay, but at some point, and let's go ahead and make a point there, that will begin to, it'll still go up, it'll go up at a slower rate. So now we're going to have total product going up in that manner. Do you see how that's now curving in the other direction? So it's going up slower and slower. And in fact, it may actually reach a peak. We're going to make a point there where it reaches a peak. And it could be that if you just put so much variable input into this, people are all running into one another and actually decreasing the total amount of output or total product. So I'm going to call this TP, this curve. And we'll just put this as a box so we get it out of the way. Okay, there. All right, so I'm going to draw some dotted lines down from those points that we just highlighted so that we can mark those for later. And here we go. Okay. Now, let's show you how this graph relates to the graphs for marginal product and average product. So what I'm going to do is I'm going to stack this with another diagram. And what we'll have here is something that has the same x-axis, labor, measured in the same units, and a different y-axis. So here we'll have marginal product and average product instead of up above where we had total product or output. Now we're going to bring these dotted lines that we had above straight down because we are working with the same x-axis. And I'll show you how that is really useful here. As long as this total product curve was curving upward, okay, growing faster and faster, that means that the marginal product here on the bottom diagram is going up. Okay? And as long as that is still positive, it's still, the total product is still going up, but it's going up at a slower and slower rate. That means that the marginal product is actually falling. And when total product reaches its maximum here, and if you went any further by inputting additional labor, total product would actually fall. That means that the marginal product crosses the x-axis and becomes negative. Okay, so we now have our whole marginal product function derived from the total product curve. And it's probably time to just notice here that marginal product is the change in total product divided by the change in the variable input, in this case labor, which is exactly equal to the, delta TP, that's the y-axis, delta L is the x-axis. So that is rise over run. So that is simply the slope of this total product curve. So what we're saying down here in the bottom diagram is that the slope is positive and rising, the slope is positive and falling, and finally the slope is actually negative when you go past this second dotted line. So now I'm going to add the average product curve. First, let's just recall that average product is equal to total product divided by the variable input, in this case labor. Notice there's no deltas, no change in. So it's just the total amount of total product divided by the total amount of labor at any level of labor input. So what we're going to have here is a curve that's going to rise for a while, and it's going to reach a peak where it crosses the marginal product curve, and then it's going to fall. And I could show you that with a little bit more geometry, but I think that's more detail than you probably need. So that is the shape of the average product curve. Now the last thing I'd like to use this graph to do is to show you the relationship between marginal and average product. Now notice that as long as the marginal product, I'm going to just highlight this area here, is above the average product, the marginal product is above the average product, the average product is consistently rising. Okay? Now let's look at the other half of this diagram. As long as the marginal product is actually below the average product is falling. Okay? So I want you to really remember that principle. When the marginal is above the average, it pulls the average up. When the marginal is below the average, it pulls the average down. And a very good analogy for this is to think about your grade point average. You know what your grade point average is probably, and you know that if you take a single course in the following semester, if that grade is higher than your grade point average, it will be the marginal grade and it will pull your average up. If you take that course and your marginal grade is below your grade point average, it will pull your grade point average down. And again, the important point to take away here is the very dynamic importance of the marginal. And we're going to see, throughout economics, that the concept of the marginal is where kind of the action is. That is where we focus our attention.